Think of a Flutter widget not as a physical button or text box on your screen, but as a lightweight blueprint. In traditional iOS or Android development, UI views are long-lived, mutable objects that you mutate directly. Flutter completely discards this model. Instead, every single widget is an immutable configuration, a simple, cheap instructions manual that tells Flutter how to draw something. When you want to change the UI, you don't modify the existing widget. You discard it entirely and spin up a new lightweight blueprint. Flutter can instantiate thousands of these per frame without sweating because they are incredibly cheap memory allocations. To understand why widgets are so fast, we need to look behind the curtain at Flutter's three-tree architecture. When you write Flutter code, you build a widget tree. But Flutter doesn't render this tree directly. Underneath it sits the element tree, which acts as the lifecycle manager and controller. Below that sits the render object tree, which actually handles layout constraints, painting, and hit testing. Your widgets are destroyed and recreated constantly, but the underlying element tree remains stable, recycling the expensive render objects. This separation of concerns is what allows Flutter to hit 60 or even 120 frames per second on modern mobile screens. Let's look at the simplest type of widget, the stateless widget. As the name implies, it has no internal state that changes over time. Once it is built, its properties are final. Here is the standard implementation of a custom stateless widget. Notice that all of its member variables are marked with the final keyword, enforcing strict immutability. The entire rendering logic is packed inside the build method, which receives a build context. This context is actually the corresponding node in the element tree, giving the widget access to its location in the hierarchy and ancestral data. Now, what if our UI needs to change dynamically, say, a counter incrementing on a tap? For this, we use a stateful widget. Unlike its stateless sibling, a stateful widget is split into two distinct classes. First, we have the stateful widget itself, which is still immutable and gets recreated when its parent updates. Second, we have a separate state class. This state object is mutable and persists across builds, safely holding onto your variables like integers, text input strings, or network response models. This clean separation ensures that while your visual blueprints remain cheap and disposable, your app's actual data stays stable in memory. Let's trace the lifecycle of a state object, which is vital for writing bug-free apps. When a stateful widget is inserted into the tree, Flutter calls createState and immediately triggers initState. This is the single best place to perform one-time initializations, like opening a database cursor or kicking off an API call. Next build is called to draw the UI. If we modify our variables inside a call to setState, Flutter marks this element as dirty, queuing it up to rebuild on the very next frame. Finally, when the widget is removed from the screen, dispose is triggered, letting you clean up memory leaks. Choosing between stateless and stateful widgets is the foundation of clean Flutter architecture. A good rule of thumb is to default to a stateless widget whenever possible. They are easier to test, simpler to read, and have virtually no performance overhead. You only need a stateful widget when the widget itself needs to manage self-contained state, like an active text input controller, a loading spinner toggle, or an animation controller. If your state needs to be shared globally across multiple pages, you should use stateless widgets combined with an external state management solution like Provider, Riverpod, or Block.